Hello everyone, welcome to the BYJU'S Exam Prep, the most comprehensive app for all competitive exams. This is Sanjay Sir. Now in this session we are going to discuss EDC, that is Electronic Devices and Circuit. It is a part of Barc 2023 Super 15 series and we are going to discuss around 15 important numericals. But before that, please inform me that sound quality, picture quality, everything is fine. Yes, please. And everyone, please join the session now. Yes, guys, please join the session. Okay. As you know, this is one of the most important and core subject for Electronics and Telecommunication branch. Definitely, we can expect what number of important questions from this subject. That is what EDC. And I'm going to cover what questions from Semiconductor Physics, PN junction, BJT, MOSFET, Special Diodes. These are the important 5 topics. Okay. So before this is my introduction. Myself Sanjay Sir. I'm having around 21 years of teaching experience. I have qualified and selected for engineering services exam. These are my ranks. And I have mentored more than 1 lakh students for the competitive exams like ECE, GATE and other PSUs like Barc, ISRO, DRDO and so on. Okay, so please use my experience and start your preparation as early as possible. Okay, अब तो ज़्यादा टाइम बचा नहीं है. On 8th and 9th April you have to give the Barc exam. होप सो आप लोगों की प्रिपरेशन बहुत अच्छी हो रही होगी. क्वेश्चन प्रैक्टिस कीजिए, मॉक टेस्ट दीजिए, बिकॉज यू हैव टू सॉल्व 100 क्वेश्चंस विद इन 2 hours. 3 marks for each question, 1 mark for wrong questions. Okay, negative marking. There is a negative marking. Okay, then guys, this is a free workshop by Sanjay Sir, MTech from IIT Roorkee. 5 ultimate steps to get AIR under 100 in GATE 2024. That is on 21st March, means today at 7:30 PM. Okay, एक बार जरा मुझे इन्फॉर्म कर दीजिए, साउंड क्वालिटी, पिक्चर क्वालिटी, एवरीथिंग इज फाइन. Okay, I think everything is fine now. Then to note the time at 7:30 PM on 21st March. So this is the first question from Electronic Devices and Circuit. Everyone try to give me the answer for this question. Again, it is a very easy one. Now, but you can expect this type of questions. Yeah, please read the question. An N-type silicon sample is uniformly illuminated with light which generates 10 to the power 20 electron hole pairs per centimeter cube per second. That is what? This is the rate of generation. The minority carrier lifetime in the sample is 1 microsecond. In the steady state, the whole concentration in the sample is approximately 10 to the power x, where x is an integer. The value of x is, right? This is a very basic question, very simple question, and generation rate is given, mean lifetime is given. Then simply you have to find the what is the concentration of hole in this case. What is the concentration of hole, everyone? Now try to understand. If you know what is the generation rate, then this is given by concentration upon tau p, or mean lifetime. So what is the concentration of hole? It will become G into what? Tau p. G into tau p. Generation rate, that is the 10 to the power 20 electron hole pairs per centimeter cube second. Okay, so this is the called generation rate, 10 to the power 20. Mean lifetime means this is given minority carrier lifetime 1 microsecond. 1 microsecond means 10 to the power minus 6 second. Then it will become 10 to the power 14 per centimeter cube, because second cancel out and 10 to the power 14 per centimeter cube. This is called concentration. The unit of concentration is not given here. This is only 10 to the power x is given. So by default the unit is what? Per centimeter cube. By default the per centimeter cube, and that's why the answer, the value of the x is what? 10 to the power of, that is the 14. Now be careful about the unit. If suppose they will provide you what? Yes, Pinky, that your answer is correct. But suppose they are giving 10 to the power x per meter cube. Then what is the value of x? Is there any change? Is there any change? That is the 10 to the power x per meter cube. So we are getting 10 to the power 14 per centimeter cube. You can write 10 to the power 14 per centimeter means what? 1 meter is equal to 100 centimeter. So 1 centimeter is equal to 10 to the power minus 2. Then it will become 10 to the power minus 6 meter cube. And then it will become 10 to the power 20 per meter cube. Then the value of the x will be what? 20. Then the value of x will become 20. So be careful about the unit, right? They can change the unit, right? Similarly, it may become what? Mm cube, or it may become what? Meter cube, or what? Centimeter cube. So this to check the unit and then give the answer for this particular question. Now next one, next question. Okay. This is about the p-n junction. This is about the p-n junction. And in an abrupt p-n junction, the doping concentration on the p side and n side are Na and Nd. That is p side and n side doping concentration is given. You can make a diagram. Then this is Na, this is Nd. Na is given as 9 into 10 to the power 16. Nd is given as 1 into 10 to the power 16. Means Na side it is 9 times greater than the Nd. The p-n junction is reverse biased and the n side depletion width is 3 micrometer. N side depletion width is 3 micrometer. This is the n side and this is p side. And there will be the depletion width. This is the depletion width. Right? When the doping is high, depletion width is the low. When the doping is low, depletion width will be high. This is the depletion width on n side. This is the depletion width on p side. What is the relation? Na into Wp is equal to what? Nd into Wn. It will satisfy this. This is the Wp is the depletion width on the p side. Wn is the depletion width on the n side. Then the p-n junction is reverse biased. The depletion width on the p side. Depletion width on the n side is given. So what is the depletion width on the p side? So that is the 9 into 10 to the power 16. 1 into 10 to the power 16. And what is the Wn? It is given 3 micrometer. This is cancel out. And then Wp will become 3 by 9 micrometer. And what is the unit? Micrometer it is given. That is nothing but 1 by 3. 1 by 3 micrometer is the answer. 1 by 3 micrometer is the answer. Okay. So if the concentration increases by 9 times, depletion width will decrease by the 9 times. And that is the answer B. B for Bombay. Directly you can use that formula directly. Okay. If the concentration increases by 9 times, depletion width will decrease by the 9 times. Okay, within 20 seconds you have to give the answer for this type of questions. Not more than that. Okay then, next one. What is the answer? Consider an n-channel MOSFET having width W, length L, electron mobility in the channel is mu n, oxide capacitance per unit area is COX. So number of students will waste their time for reading all these lines. So quickly read this point W. We have the idea mu n on oxide capacitance per unit area. Very quickly, because these all are the standard diagram. What is asked here? If the gate to source voltage, this is the important thing, VGS. VGS is given as 0.7 volt. Drain to source voltage, VDS, is given as 0.1 volt. Mu n COX, that is nothing but K and S. Mu n COX is given as 100 microampere. Normally convert it into milliampere. Milliampere per volt square, that is 100 microampere is converted into milli. Threshold voltage is 0.3. W by L, that is called aspect ratio, 50. Then the transconductance GM. Transconductance GM in milliampere per volt is. What is the transconductance? Tell me. If you want to find the transconductance, then first of all check whether it is in triode region or saturation region? Tell me. What about the MOSFET? It is in triode region or saturation region? No doubt it is not in cutoff region. Why not in cutoff region? Because the VGS is greater than what? VTH. If the VGS is greater than VTH, not in cutoff. Not in cutoff. It may be in triode or it may be in saturation. You have to check the condition. What about the VDS? VDS is given as 0.1 volt. And what is the VGS minus VT? VGS minus VT 0.7 minus 0.3, that is 0.4 volt. And VDS is less than VGS minus VT. If the VDS is less than VGS minus VT, means it is in tell me which region? Triode region. If it is in triode region, then write down the formula for what? Triode region. What is the formula for the triode region? IDS is given by K and S. K and S is nothing but mu and CUX. W by L. VGS minus VT into VDS minus half of VDS square. But what is asked? GM. GM is nothing but DIDS by DVGS. Differentiate with respect to VGS. It will become K and S, W by L. Now what is the differentiation of this? It will become 1 and this is the VDS. What is the differentiation of this? 0. Finished. Now this is the value of the GM. K and S is nothing but mu and CUX. So what is the mu and CUX is given? 0.1 milliampere. W by L is given as 50 and already you have calculated VDS is given as 0.1. 0.1 it will become 0.01 into 50. What is this? 0.5. 0.5 milliampere per volt. And that is the unit of GM, transconductance. Okay. So that is again with respect to what? To VGS, not VDS. If it is asked what is the GD, then this is called change in ID because of change in what? VDS. Change in ID because of change in VDS. But what is asked? GM is asked. Then what is the answer? 0.5. So which answer is correct? This one. Otherwise, student will calculate what? GM. What is the GM? Change in ID because of change in VGS, and standard formula K and S, W by L, VGS minus VT. K and S is given as 50. What is the VGS? 0.7 minus 0.3. Then it will become 0.1 into 50 into what? 0.4. Then 50 into 0.4, that is what? 20. 20 into that will become 2. I think that is the correct 2. Right. So if you are getting the 2, then this is what? Wrong answer. Is it in answer 2? Okay, it is not given in the answer. Otherwise, you are going to make a mistake here. If suppose the A option is 2 and directly without watching the question, if you are giving this formula, then A answer will be correct. Once you will get the answer in given option, then there is it will be wrong answer. Which square? Which one is square? No, I am talking about the GM. In saturation region, what is the current? Half of K and S, W by L, VGS minus VT, the whole square. So what is the GM? Differentiation of this. What is this? When I am differentiating, it will become K and S, W by L, this 2 cancel out. VGS minus VT. Okay. So this is the formula for GM. I am saying it is in saturation region, but the given circuit is in triode region. तो आराम से बनाओ, कोई हड़बड़ी करने की जरूरत नहीं है. कुछ भी आप आराम से रीड कीजिए क्वेश्चन को, और जो मिस्टेक्स आपने गेट एग्जाम में अगर की है, सिली मिस्टेक्स आपने की है, तो आप देखिए गेट का पेपर इलेक्ट्रॉनिक्स का इस बार काफी मतलब इजी था एज कंपेयर टू लास्ट ईयर. तो वैसे ही अगर टफ आ रहा है, इफ द पेपर इज टफ देन इट इज टफ फॉर एवरी स्टूडेंट। आप वॉच कीजिए इलेक्ट्रिकल स्टूडेंट, इलेक्ट्रिकल में 66 मार्क्स हाईएस्ट गए, हाईएस्ट मार्क्स, और लास्ट ईयर 92 क्रॉस किया था। तो अगर लास्ट ईयर के हिसाब से कोई जानबूझकर यार क्वेश्चन नहीं बन रहा है, जानबूझकर अगर गलत गलत मिस्टेक करके आ जाए तो दिक्कत है ना। और जिसमें कोर सब्जेक्ट में से कुछ बनाया होगा और बाकी जो साइड के सब्जेक्ट है, नेटवर्क है, डिजिटल है, और आपका एनालॉग है, सिग्नल एंड सिस्टम एंड सो ऑन, मैथ्स है, एप्टीट्यूड है, सिग्नल तो नहीं है, अगर उनमें से भी इलेक्ट्रिकल वालों ने ढूंढ के बनाया होगा तो आपको आपकी रैंक आ जाती है अंडर 10। तो यहां पर भी बार्क में भी आप वैसे ही प्रिकॉशन लीजिएगा। अगर थोड़ा भी आपको लगे पेपर टफ है तो एक्यूरेसी मेंटेन कीजिए, नॉर्मल पेपर है तो आप अपनी स्पीड मेंटेन कीजिए विद टाइम मैनेजमेंट भी और एक्यूरेसी। गलत नहीं करना है, सिली मिस्टेक्स अवॉइड कीजिए। पेपर वही क्वेश्चन आते हैं, कई लोगों को लगेगा बहुत एक्स्ट्रा ऑर्डिनरी सर करवा दो। एक्स्ट्रा ऑर्डिनरी क्वेश्चन साल भर प्रैक्टिस के लिए होते हैं। अब जब एग्जाम टाइम है तो मॉक टेस्ट दीजिए, ज्यादा मॉक टेस्ट आप देते रहिए ताकि आप अपनी स्पीड मेंटेन कर सके। बताइए क्या होगा, ये तो हो गया इसका आंसर। अब बताओ इसका आंसर क्या है। इन अ मॉस कैपेसिटर विद एन ऑक्साइड लेयर थिकनेस ऑफ 10 नैनोमीटर, oxide layer, the maximum depletion layer thickness is 100 nanometer. The permittivities of the semiconductor oxide layer epsilon s, epsilon x respectively, assuming that ratio is given, the ratio of the maximum capacitance to minimum capacitance of the MOS capacitor. Now this question is related to what? MOS capacitor. Okay guys, now tell me what is the answer. This is the oxide thickness, this is the metal plate. Okay. Now, if this is the oxide thickness, TOX. Now, there is a depletion layer means what? Because a MOS, it is not given, it is whether it is N type or P type, it doesn't require. For example, if it is a N channel MOSFET, then the body type is P type. And then it is called depletion layer. Then it is called depletion layer. Now what is the depletion layer is given as 100 nanometer. This is the maximum. This is called exactly at threshold 100 nanometer. And this TOX is given as 10 nanometer. And this is the SiO2 layer. What is epsilon X? And this is the silicon. For this the permittivity is epsilon S. The capacitance of this portion is given by per unit area, epsilon x by TOX. Capacitance of this is given by CS, epsilon s by what? Depletion width. But when the depletion width is maximum, this is called depletion width. But when the depletion width is maximum, this is called XT. XT means exactly at threshold. This is maximum depletion width. Then it will become minimum. Then it will become minimum. Now, according to the curve, what is the ratio? Then C minimum, overall capacitance C minimum is nothing but series combination of COX and CS minimum. So COX, CS minimum divided by COX plus CS minimum. This is called overall minimum capacitance. According to the characteristics, exactly at threshold, we are going to get the minimum capacitance. Minimum capacitance. This is the point of minimum capacitance. After that, this is the case. Now, at this point, we are getting the minimum capacitance. This is the VGS. This is the C. CV characteristics. At VT, we are getting the C minimum capacitance. Here it is the oxide capacitance. Here it is the oxide capacitance. Here it is the minimum. So this is the maximum capacitance and this is the minimum capacitance. So what is the minimum capacitance? Series combination of CS minimum and COX. And what is the maximum capacitance? COX. What is the ratio? Now remember the ratio CS minimum by C minimum. when we are dividing, COX cancel out. Upon what? COX plus CS minimum. So this is cancel out and it will become COX plus CS minimum divided by CS minimum. And now you can write what is the ratio? C maximum upon C minimum. It will become 1 plus, this is divided 1 plus COX upon what? CS minimum. What is the COX? Epsilon naught by TOX upon CS upon XDT or XT. COX upon epsilon x by TOX, and this is epsilon s by XDT. So what is the ratio now? Always remember this formula directly. You can use this formula, epsilon x by epsilon s into, this will become XDT upon what? XTOX. XDT upon TOX. Okay, that is the important formula. Nandesh Krishna, how are you? Now, what is this epsilon? So now directly in this case, directly you can use this formula. 1 plus XDT upon TOX, and just opposite of that. Epsilon s. 1 plus 100 by 10 into, what is the ratio? Epsilon x by epsilon s. Epsilon x by epsilon s. This is that given as 3. So what is the opposite? 1 by 3. So that will become 10 by 3 and this has become 13 by 3. 13 by 3 is the answer for this question. 13 by 3. So which answer is satisfied? 13 by 3 means what? 4.4. ओके अब एक बात बताना, अगर आप एग्जाम हॉल में डेरिवेशन करेंगे तो फिर तो बार्क में आप क्वेश्चन नहीं बना पाएंगे. आपको डायरेक्ट ये फॉर्मूला लिखना है, 1 प्लस XDT अपॉन TOX अपॉन इंटू एप्सिलॉन x बाई एप्सिलॉन s. दैट इज द रेशियो ऑफ द मैक्सिमम अपॉन मिनिमम. कोई भी आप फॉर्मूला तो निकाल लोगे लेकिन उतना टाइम नहीं है. गेट में आपके पास टाइम होता है. एंड गेट द आइडिया अबाउट दिस कर्व. हियर व्हाट इज द नेम ऑफ द मोड? दैट इज द एक्यूमुलेशन मोड, डिप्लेशन मोड, inversion mode, strong inversion. It is a low frequency response. If this is the curve, then it is called high frequency response. That is called CV characteristics, right? CV characteristics. Okay, then next one. अब बताइए इसका आंसर क्या होगा? The dependence of the drift velocity of electron on electric field in a semiconductor is shown below. This is the drift velocity, 10 to the power 7 it is given. And this is 10 to the power 5 it is given. 5 into 10 to the power 5. This is 10 to the power 7 drift velocity versus electric field. First of all, it will increases linearly, then it will become constant at 5 into 10 raised to power 5. That is called saturated drift velocity. It is given as 10 to the power 7. That is the relation between the electric field and drift velocity. The semiconductor has a uniform electron concentration 10 to the power 16 per centimeter cube. And the electronic charge is given if the bias of 5 volt is applied across a 1 micrometer region of this semiconductor. The resulting current density in this region. What is the resulting current density? Read the unit kilo ampere per centimeter square. Means there is a bar. This is a semiconductor bar. Here we are applying the 5 volt. And what is the length of the bar? Length of the bar is given as 1 micrometer. 1 micrometer. So first of all, convert the micrometer into centimeter so that we can find the electric field. So what is the electric field? E is equal to V by length. 5 upon 1 micrometer means 10 to the power minus 4 centimeter. So it will become 5 into 10 to the power 4 volt per centimeter. That is the electric field, 5 into 10 to the power 4. Now, the graph this is the graph. What is the saturated velocity? 10 to the power 7. What is the value at this point? 5 into 10 to the power 5. This is the electric field and that is the drift velocity. Now the value of the electric field applied is 5 into 10 to the power 4. So where is the 5 into 10 to the power 4? At this point. 5 into 10 to the power 4. Okay. If this is the case, 5 into 10 to the power 4, then what is the equation of this line? Equation of this line, we have the slope, and that is what we can find the equation for this line. What is the relation between drift velocity? On y-axis we have the Vd, on x-axis we have the E, and the slope of this line is given by 10 to the power 7 divided by 5 into 10 to the power 5 into what? Electric field. Because what is the equation of the line? Y is equal to mx plus c. So what is the interception here? 0. What is the slope here? 10 to the power 7 divided by 5 into 10 to the power 5. That will be the slope. And this is the, what is the x? X-axis is the electric field. So it will become, you can write it like that, 100 into 10 to the power 5 divided by 5 into 10 to the power 5. So this is cancel out and this will become what? 20. This will become 20. The slope is 20 and therefore it is 20 into E. And what is the actual electric field? 5 into 10 to the power 4. So you can find the drift velocity at that point. 20 into 5 into 10 to the power 4. Then it will become, this is the 100 into 4, 10 to the power 4 means what? 10 to the power 6. 10 to the power 6 centimeter per second. This is the drift velocity at this point, 10 to the power 6. Find the slope, get the value. This is the equation. Okay. Now once you will get the Vd, so what is the question asked here? Why we are finding the value of Vd, drift velocity? N is given, Q is given. If the bias of 5 voltage electric field is given, the resulting current density in this region. What is the current density? J. So current density J means sigma E. Sigma means NQ mu n into what? E. And what is the mu n into E? It is nothing but drift velocity. It will become NQVD. So N is given in the question. N is given in the question 10 to the power 16. Q is given, already we have calculated the Vd. That's why into 10 to the power 6. Already we have calculated the drift velocity 10 to the power 6 centimeter per second. Then it will become, this is 6, 22, 22 minus 19, 3. 1.6 into 10 raised to power 3, right, ampere per centimeter square. And that's why we can say 1.6 kilo ampere per centimeter square. That is the unit of current density J, I by A. Okay. So this is the answer for this question. So current density means simply I by A. That is the formula. Okay then I think now this question is clear. So 1.6, this is the answer. To get the idea about the current density, this is the drift current density. Find the formula. What is the formula for the diffusion current density? How we can find with the help of what? Concentration gradient. What is the difference between the drift and diffusion current? These are the important question. Next one. Okay. At T equal to 300 degree Kelvin, the whole mobility of a semiconductor is this one. KT by Q is 26 millivolt, the whole diffusion constant. भाई आप लोग भी जवाब दीजिए क्या है आंसर. What is the answer for this question? What is the answer? Yes, please. Tell me what is the answer for this one. Okay then. This is a simple Einstein equation you have to use. This is a very simple question. Einstein equation you have to use here. So what is that is the KT by Q is nothing but VT. The whole diffusion constant, it is asked, this is also called sometimes coefficient, mu P into what VT. Mu P it is given in the question 500. Always remember the unit centimeter square per volt second, and it is in volt, 0.026 volt. Multiply it and you will get the answer. Simply it is a half of that, means it is a 13. No need to use the calculator here. No need to use the calculator here. Yes, directly we can use the Einstein equation. So directly sometimes we may expect what this type of very easy question from this, no problem. Then this is the Einstein equation. Then tell me what is the answer for this one. What is the answer for this question? Now, under low level injection assumptions, the injected minority carrier current for an extrinsic semiconductor is essentially the low level injection means, if this is the case, let this is a bar, and for example we are giving the radiation at this point, then there will be the low level injection. Now the new hole electron pair will generated here. When new hole electron pair will generated here, so at the far end the number will remain same, but here the new electron hole pair generated. For example, at this end initially N0, initially N0, initially P0, initially P0, but when we are giving the radiation, it is increased by del N, it is also increased by del P, and del N is equal to del P. Why? Because new hole electron pair generated. So the change in the concentration of electron and change in the concentration of hole will remain same. Now the concentration of electron increases as well as concentration of hole increases at this end, but the far end there will be no change. Far end there will be no change, and that's why the charged particle will move from this point to this point. Under which phenomena? Diffusion or drift? Under which phenomena? From higher concentration to what? Lower concentration. When the charged particle move from higher concentration to lower concentration means what? This is the diffusion phenomena. The diffusion. So under low level injection, and the electric field developed is what? Because concentration is very small. Minority carrier concentration is very, very small, and that's why the drift current is negligible because of that low level injection. Low level means what? Injected minority carrier current. It word is used here. Injected minority carrier current. For drift current, it depends upon the concentration. Drift current density is what? N Q mu N into E. It depends upon the concentration. If the hole is the minority carrier, it is what? P Q mu P into E. If the concentration is low, then what about the current? Current will be low, and that is mainly because of diffusion phenomena. That is mainly because of diffusion phenomena. No, I am not talking about the external electric field. There will be the development of what? Internal electric field because of this concentration gradient. In any open circuit bar, the current should be equal to 0. Right, there is a complete derivation. Already I have given the complete derivation in my one session or in paid classes, so please watch that. So this is an important diagram. Now tell me, a region of negative differential resistance. Region of negative differential resistance. Negative differential resistance means di by dv. This is called slope, and slope is what? Negative. Means when we are increasing the voltage, current will decrease. That is also called negative conductance region, negative resistance region. So here we are getting negative resistance. Negative resistance device, give the name of the negative resistance device. Right, everyone? So negative resistance, then this type of characteristics. Okay. Peak current, valley current, peak voltage, valley voltage, IV characteristics. This portion is called negative resistance because V increases, I decreases. Negative resistance region. Okay. So it is in what? Tunnel diode, gun diode, right? Right. So it is talking about the tunnel diode. So in a tunnel diode, we have the negative resistance region. And for that, the doping on both the side. In case of tunnel diode, the doping is very high. Therefore, there is a tunneling phenomena. Very, very high. Na is very high, Nd is very high, and that's why the depletion region is very thin. And there will be the tunneling phenomena. Depletion layer is very, very low because doping is very high. 1 part in 10 raised to power 3. And we are having the negative resistance area. Negative resistance is used for amplification or for what? Oscillation. Positive resistance will consume the power. There will be the dissipation of the power across the positive resistance. And the negative resistance will deliver the power. It will deliver the power. And that's why we can make what? Amplifier, or we can make what? Oscillator, when the tunnel diode is biased in negative resistance region. Okay. So ये है इसका. What is the another name of tunnel diode? So this is both the P region and N region are heavily doped. 1 part in 10 raised to power 3. 1 part in 10 raised to power 3. Now, compared to the PN junction with Na is equal to Nd is equal to 10 to the power 14, which one of the following statement is true for PN junction with Na is equal to Nd is equal to 20? Na is equal to Nd is equal to 20. Right? Tell me. What is the answer? Negative what? Simple. When I am saying that, what is the positive resistance? Just equivalent circuit now. Watch this equivalent circuit. This is the R, this is the RL. And I am applying any voltage Vs. Tell me, what about the output voltage? So according to voltage division rule, it will become RL upon R plus RL into Vs. This factor is always less than 1, and that's why this quantity is less than Vs. This is called attenuation. This is called what? Attenuation. But if suppose it is a negative resistance, let the value is what? Negative. Now this is the Vs. Now what is the, according to voltage divide rule? RL upon RL minus RL. Actually we want to add, but it is a subtracted here into V naught. Now try to understand. For example, I am giving it, this is the 10. This is the 10, but it is the let minus 5. Minus 5 into Vs. Tell me 10 divided by 5. 10 divided by 5 is 2 times of Vs. Or here it is less than Vs. For example, if it is positive value 10 divided by 5 plus 10, then it will become 10 divided by 15, 2 by 3 Vs. So here the output is less than Vs, here the output is greater than Vs, means there is what? Amplification. There is what? Amplification. Okay. So that is the property of negative resistance. or exactly when RL magnitude will become equal. The magnitude will become exactly equal. Rn and Rn are equal magnitude. For example, it is 10, it is minus 10. Then what will happen? That factor will become infinite. That factor will become what? Infinite. RL by 0, it is infinite. And in that case, it acts as what? Oscillator. There should be a finite output without any input. Then the gain of the system should be what? Infinite. So V0 upon Vi will become infinity. V0 by Vs will become infinite. So this is the case. So these are the extra cases. This is the equivalent circuit. I think now it is clear. Okay. Compare to a PN junction with Na is equal to Nd is equal to 10 to the power 14. The doping is low. And in second bar, the doping is very high. Na is equal to Nd is equal to 10 to the power 14. Na is equal to Nd is equal to 10 to the power 26. 10 to the power 6 times higher. So suppose we are increasing the doping. If suppose we are increasing the doping, then the breakdown voltage will decrease. Always remember. When we are increasing the doping, depletion width will decrease. Depletion width will become very narrow. And because of that narrow, when we are applying the very low voltage, there will be the very high electric field, and that's why the breakdown voltage is decreases. Breakdown voltages decreases. For example, in case of Zener diode, there are two mechanisms, Zener and avalanche mechanism. In a Zener mechanism, the doping is very high, and the breakdown voltage is low. Or avalanche mechanism, doping is low, that's why the breakdown voltage is high. Normally greater than 6 volt, normally less than 6 volt breakdown voltage. Second important thing, reverse breakdown voltage decreases. Depletion capacitance or transition capacitance. What is the depletion or transition capacitance? Epsilon A by W. So when the doping increases, what about the W? Decreases. When the W decreases, so what about the capacitance? Increases. W decreases, so capacitance increases. Sir. Yes. Without input means what? Without input means there is no signal. Right? Energy can neither be created nor be destroyed. Yes. So when I am saying that there should be output without any input means I am saying that we are not giving any AC signal as an input. We are getting the output AC signal, but we are not giving any AC signal as an input. In amplifier again, this point is clear everyone. Which answer is correct? Reverse breakdown voltage is lower and depletion capacitance is higher. See. Okay then. Now next one. So again in amplifier, we are giving the signal. There is a bounded output for bounded input, and this signal is amplified. And here we are giving the DC supply, mainly DC supply, or in sometimes we are also giving the, in one or two cases, we are also giving the AC signal also as an input, as a power supply. For example, in what there was a parametric amplifier and so on, we are again applying the AC is converted into AC, but normally we are applying the DC in case of MOSFET, in case of BJT. Now, in case of oscillator, what is the input? 0. We are getting the output. There is the output without any input because the gain of the system is infinite. No doubt we have to apply the DC signal here. This DC is converted into AC. DC is converted into AC. The DC power is converted into AC power. Okay. I think now it is clear. Then next one. Sometimes a very basic question. If for a silicon NPN transistor, the base to emitter voltage is 0.7 and the collector to base voltage is 0.2, then tell me what is the answer. Divide. Sir, try to avoid what silly mistakes. First of all, make NPN transistor. This VBE is given as 0.7 volt. This is the base terminal. This is the emitter terminal. Means it is a forward bias. For base is connected to positive value. And the VCB means from this point to this point. Collector at higher potential than the base means that junction is reverse bias. This junction is reverse bias, then it is called normal active mode within 20 seconds. Tell me, what about this transistor? What is the answer for the second question? This is the first one, this is the second question. Normal active mode, saturation mode, inverse active mode, cutoff mode. This is simply short circuit the collector to base. Collector to base junction is simply short circuited, and here it is the 0.7 volt is connected here, right? Again in this case, if the transistor, if we are simply short circuiting the collector and base, this is the VB, short circuiting the collector and what, base terminal, then again it is in what, not in saturation region, this is in what, normal active region. It will never goes into saturation. This is not the question of what, MOSFET. In MOSFET we are saying that because this is the MOSFET, when the drain is connected to gate, this is called in saturation region. Similarly in BJT, when the collector is connected to the base, then it is called active region, normal active mode. By in MOSFET, the saturation is equivalent to what, active. Cutoff means cutoff. And here the triode means what? Here it is equivalent to what, saturation here. In active region it acts as amplifier, in saturation region it acts as what, an amplifier. That is the difference. But when the collector is connected to base, it is in active region, drain is connected to gate, it is in saturation region. Okay, remember that. Normal active mode. Yes. Now next question. For an N-channel enhancement type MOSFET, if the source is connected to a higher potential than that of the bulk, then that of the bulk means body. This is the body, N plus, these are the source, drain, it should be reverse bias. This junction should be reverse bias. So normally we are making it short circuit, but if we are connecting a battery VSB that is greater than 0 volt, again it is a reverse bias, because N is connected to positive terminal and P type body is connected to negative terminal, because N channel enhancement type, this is the N channel enhancement type MOSFET. This is more reverse bias, right? And that's why the threshold voltage, directly you can watch the formula, or directly we can say, if it is connected here, right, then guys, the threshold voltage will what? Threshold voltage increases. Threshold voltage increases. So revise the formula, revise your formula notes about the threshold voltage and what is the role of this and so on. The next one. The source of silicon, that is intrinsic carrier concentration, is given as 10 to the power 10 per centimeter cube. N-channel MOS transistor has an area of 1 square, right, meter and a depth of 1 picometer, right? Area of 1 square picometer and the depth of 1 picometer. If the dopant density in the source is 10 to the power 19 per centimeter cube, the number of holes in the source region with the above volume is approximately. What is the volume? The area is given 1 square picometer, right? That is the area. This is the bar. Source of the silicon. This is the source. right? Right. So 1 square per meter, this is the cross sectional area, and then depth of the 1 picometer. You can multiply it. Now if the dopant is 10 to the power 19 per centimeter cube, the number of holes in the source region with the above volume is approximately, what is the answer? So first of all, what is the concentration? According to mass action law, Np is equal to Ni square. So what is this? Is the source region, source of the silicon per channel, N channel MOSFET, means source is what? N positive area. I am just simply giving you the source only. So it is an N positive source. So what is the N? N is nearly equal to Nd. What is the Nd? Is given 10 to the power 19. So what is the P will become? 10 to the power 10 square divided by 10 to the power 19. So this is the 10 to the power 20 divided by that. That is the answer per centimeter cube. 10 to the 10 per centimeter cube. It is the concentration. It is the concentration. So which answer is correct? Now read question carefully. Source of silicon, N channel MOS transistor has an area of this and depth of this. The number of holes. It is not asked concentration. Remember on this. Not asked concentration. What is asked here? The number of holes. Number of holes, not the concentration. Actually, it is a concentration. So you have to find the volume. So number of holes means what? Concentration into volume. So volume, first of all, area into depth. So what is the volume here? Volume will become area. What is the area? Square picometer means, remember what is the volume? Volume is very, very low. 10 to the power 1 picometer means what? 10 to the power minus 12. And then square of that, it will become 10 to the power minus 24. That is the area into what is the depth? 1 picometer. So 10 to the power minus 12. 10 to the power minus 36 meter cube. That is the volume. And in centimeter, it will become 10 to the power minus 36 into 10 raised to power 6, because 1 meter is equal to what? 100 centimeter. So 1 meter cube means what? 10 to the power 6. It will become 10 to the power minus 30 centimeter cube. 10 to the power minus 30 centimeter cube. That is what? Volume. So volume means what? It will become number of holes, concentration. So what is the concentration? 10 into 10 raised to power minus 30. It will become what? 10 to the power minus 29. It is not a whole number. Not a whole number, right? 0. 0 we can say. Is it clear? Negligible. 0. To check the volume, check my unit also, check my calculation, but that what in a source region the doping is so high and the volume is so low that the minority carrier concentration is almost 0. Minority carrier is almost 0. Now, very easy question. Quickly give me the answer. The drain of an N-channel MOSFET is sorted to the gate so that VDS is exactly equal to what? VGS. The threshold voltage is 1 volt. If the drain current is 1 milliampere for the VGS is equal to 2 volt, then VGS is equal to 3 volt. What is the ID? Okay. Remember, once the drain is connected to the source, drain is connected to the gate, then VDS and VGS are equal. It means VDS is greater than VGS minus VT. That's why it is in saturation region. That's why it will be in saturation region. In a saturation region, what is the formula? IDS is equal to half of K and dash W by L VGS minus VT the whole square. These all are constant. That's why it is proportional to VGS minus VT the whole square. When something is proportional to that value, you can always write the formula IDS 2 upon IDS 1. is equal to VGS2 minus VT, because VT is a constant value, the whole square upon VGS1 minus VT the whole square, because it is proportional to that value. This is the formula. Directly you can write it. Now, in this first case, what is the value of the current? 1 milliampere. In second case, what is the VGS2? 3 volt. What is the VT? 1 volt. In first case, what is the VGS? 2 volt. What is the VT? 1 volt, the whole square. Then this is become 2 by 1, that is the square of that, it will become 4. What is the IDS2? IDS2 will become 1 into 4, that is nothing but 4 milliampere. Directly you can give the answer, 4 milliampere. So, देखो, no need to write this formula, no need to write this formula, no need to draw the diagram during exam, because directly it is in saturation region. Directly you can write this formula. Directly you can write this. Again, no need to write this formula again. Directly you can write this. In this way we can save our time, right? We have to solve within 20 seconds this type of question, formula based question. कई लोग ना मेंटेन एक्यूरेसी मेंटेन करने के चक्कर में बहुत ज्यादा टाइम किल करने वाले. आर यू गेटिंग माय पॉइंट? मतलब बनेगा, क्वेश्चन बनेगा, लेकिन आप मॉक टेस्ट नहीं दे रहे हैं या क्वेश्चन प्रैक्टिस नहीं कर रहे हैं, तो आप 100 क्वेश्चंस 2 घंटे में बनाना है आपको बार्क एग्जाम में. वो आपको बहुत ही स्पीड मेंटेन करते हुए चलना पड़ेगा एक्यूरेसी के साथ. तो आपको ऐसे क्वेश्चंस को बहुत तेजी से, मतलब जितनी रिडंडेंट चीजें हटाओ, क्वेश्चन में से क्या रीड करना है, विच आर द इंपॉर्टेंट लाइंस एंड सो ऑन, तो फॉर्मूला कैसे बहुत ही तेजी से अप्लाई करना है, और साथ में एट द सेम टाइम यू हैव टू अवॉइड द सिली मिस्टेक्स. तो ये चीज है. ओके, तो ये भी वही क्वेश्चन था, वैसा ही है. नाउ टेल मी लास्ट क्वेश्चन, व्हाट इट अ स्मॉल कंसंट्रेशन, रीड दिस क्वेश्चन then give me the answer. A small concentration of minority carrier is injected into a homogeneous semiconductor crystal. This is like a homogeneous semiconductor minority carrier is injected into the homogeneous semiconductor crystal. At one point, an electric field of 10 volt per centimeter is applied across the crystal, and this moves the minority carrier a distance of 1 centimeter in 20 microsecond. The mobility will be. So if that question is very simple, so what is the relation between the mobility and that electric field is also given? So we have the formula velocity, mobility into electric field. So what is the mobility is equal to Vd by E. Now E is given in the question. What about the Vd? There is a one information. When a small concentration is given at one end, and that is moved under the influence of the electric field, and it will travel 1 centimeter in 20 microsecond. So 1 centimeter is given, 20 microsecond is given. So what is the velocity? Length by time. 1 centimeter divided by 20 microsecond, 10 to the power minus 6, and it will become 10 to the power 6 divided by what? 20. 10 to the power 6 divided by 20, that is nothing but 5 into 10 to the power 4. So 5 into 10 to the power 4 centimeter per second, that is the drift velocity. 5 into 10 to the power 4. Okay, now you can put here 5 into 10 to the power 4. So mobility will become 5 into 10 to the power 4 upon E. Electric field is given as 10. So 5 into 10 to the power 3, that is nothing but 5,000. Nothing but 5,000. Okay. So directly you can use this formula and you can find a value. That is the 5,000 is the answer for this question. Then next one. The longest, that is on special diode, we can say that is the concept of LED and so on. The longest wavelength that can be absorbed by the silicon, which has the band gap of 1.12 electron volt, is 1.1 micrometer. If the longest wavelength that can be absorbed by the another material is 0.87 micrometer, then the band gap of this material is longest wave. What is the longest wavelength? That is called cutoff wavelength. Cutoff. that is also known as longest wavelength that can be absorbed by particular material. It depends upon the band gap. As you know, the band gap relation between 1.24 by lambda and what is the cutoff wavelength of EG is given. If EG is given, then cutoff wavelength is given by 1.24 by EG. 1.24 by EG, and this 1.24 is nothing but a constant, that is the K by EG. So we can say it is the inversely proportional to what? EG. It is inversely proportional to what? EG. Okay. So if it is inversely proportional to EG, then directly write K cutoff 2 divided by K cutoff 1. Because it is inversely proportional to EG1 divided by EG2. EG1 divided by EG2. What is asked here? Another material is 0.87 absorbed by the another material is longest wavelength. It is given. In both the cases 0.87 in second case, 1.1 micrometer in first case. What is the EG1? 1.12. You have to find the EG2. What is the EG2 will become? 1.1 into 1.12 divided by 0.87. That is the relation. You can use it, what is given, and then you can find it. So EG2 is what? 1.416 electron volt. Okay. And guys, remember, what is the wavelength given in the first case? 1.1 micrometer. And what is the wavelength given in the second case? Only 0.87 micrometer. Means cutoff wavelength decreases. If the cutoff wavelength decreases, what about the EG? What about the EG? Right? Cutoff wavelength decreases because it is inversely proportional. Because it is what? Inversely proportional. Right? And that's why it will what? If that decreases, it means it is increases. So which one answer is increasing? Which one is greater than 1.12 electron volt? Only one answer is greater than 1.12 electron volt. Directly without calculation you can say. Without calculation you can say answer is what? A. तो ऐसे भी आपको सेव करना है टाइम. ऐसे भी आपको सेव करना होगा टाइम. अगर इसको भी आप कैलकुलेशन कर रहे हो तो 30 सेकंड्स लग जाएंगे डायरेक्टली. और ये आपका 1.24 वाला फॉर्मूला निकालने की जरूरत नहीं है. गिवन ही नहीं है डेटा. ओके, इट इज अ स्टैंडर्ड फॉर्मूला. ओके देन लास्ट क्वेश्चन. For a MOS capacitor biased in accumulation mode, the effective capacitance in. What is the effective capacitance in accumulation mode? Tell me. What is the effective capacitance in accumulation mode? That is the case. This is the accumulation mode. That is the depletion mode. And we are having the minimum capacitance, C minimum. Already we have solved one question on that. This is called inversion mode. And that is the strong inversion. And this is a low frequency response, CV characteristics. This is the accumulation mode, and in accumulation mode it is equivalent to what? Oxide capacitance only, COX. This is the formula for depletion mode, right? This is the oxide capacitance. None this. This is the D option is for depletion mode. And in accumulation mode, the effective capacitance is only COX. Here it is a maximum capacitance COX. Once the depletion is started, the capacitance start decreasing. Exactly at this point it will reach to minimum. This is called threshold voltage. And now after that inversion will start, again capacitance will increases, and at this point when there is a strong inversion, then again the capacitance will reach to what? COX. That is called oxide capacitance. Okay, so please get the idea about all the CV characteristics and special diodes, like what already I have taken one session. Yes. Okay, and क्या पढ़ लीजिए आप लोग स्पेशल डायोड्स में, गेट द आइडिया अबाउट द सोलर सेल्स एंड सो ऑन. EDC revised got semiconductor Fermi level. Already in previous in Mahamarathon session for GATE exam, we have covered what number of questions on Fermi level. So you can watch those sessions right directly. Mahamarathon part 1, Mahamarathon part 2, EDC 1 and EDC 2. Okay then. So thank you for attending the session. This is the NILATE 2023 crash course for Electronics and Computer Science branch. Monday, Wednesday, Friday technical and every Saturday exclusive aptitude session. To subscribe our channel so that you will get the notification. And there is a one new series for you, the Coffee with Concepts. Now learn important concept of GATE exam with us twice a week. Electrical, Electronics, Instrumentation Wednesday and Sunday, and Computer Science Tuesday and Saturday. That will start from on 19th March. So you can watch that session also. Okay then, next one. Now try to give the mock test only. और अगर आपका इंजीनियरिंग सर्विसेज प्री आपने क्वालिफाई किया है, बिकॉज मेंस एग्जाम 25 जून को है, already you have qualified the engineering services pre that is conducted by what UPSC to UPSC ESE pre prelims result. To share your result with us and avail amazing benefits. You can inform me also on my Telegram channel, that is Electronics by Sanjay Rathi. Okay. This is a BYJU'S Exam Prep. Thank you for attending the session. Thank you very much. Good luck and good day.